true, false? Here we want to decide whether a function defined in this particular way is a linear transformation. So the way the function was defined, it takes a vector of size 2 into a vector of size 2, where the output's first component is the product of the components of the input vector, and its second component is the first component of the input vector. So if this is a linear transformation, it has to satisfy two conditions. F of alpha times x must be alpha times f of x for any scalar alpha and vector x. And f of x plus y would have to be f of x plus f of y for any vectors x and y. So let's check to see if it holds. Let's first start here. F of alpha times x. Well, what is that? That's f of alpha times, let's write the vector x as the vector with components chi sub 0, chi sub 1. And if we perform a scalar multiplication, that is just f of the vector with components alpha chi sub 0, alpha times chi sub 1. The result is supposed to be a vector whose first component is the product of these two components. So it would be alpha times chi sub 0 times alpha times chi sub 1, which would be alpha squared times chi sub 0 times chi sub 1. And the second component would be alpha times chi sub 0, because that's what the definition tells us to do. Now, if we look at alpha times f of x, that would be alpha times f of the vector with components chi sub 0, chi sub 1, which is alpha times, let's see, f of chi sub 0, chi sub 1 is the vector whose first component is going to be the product of of chi sub 0 times chi sub 1, and the second component is just going to be chi sub 0. When we multiply this vector by alpha, we get the vector with components alpha chi sub 0 times chi sub 1 and alpha times chi sub 0. Now, is it true that the two simplifications that we perform yield the same vectors, and the second components match, but the first components don't? The first component here was alpha squared times chi sub 0 times chi sub 1, and here it's just alpha times chi sub 0 times chi sub 1. So if alpha was something other than 0 or 1, these two would not be equal. And so, it's not the case that f of alpha x is alpha times f of x. And so we don't even have to bother any further. This particular function is not a linear transformation. It's false.